Ladies and gentlemen of calculus, good morning.
Good morning.
We are here to our ongoing investigation of particle motion, and in conjunction with position, and what else is related to position, velocity, acceleration,
speed, momentum,
speed.
violence.
And Hannah knows what speed is, right?
Absolute value of the law. Hey!
Absolutely. You're taking Hannah's thing.
Point at me.
No, that's okay. No, that's good. It's good. No, that's good.
Your name Hannah. It almost was. That doesn't count.
All right.
My name was almost.
So anyway, we have a graphical demonstration here. And we have this graph here
I'd call Zeke.
is velocity,
That's dog's name.
is velocity in feet per second of the particle moving along the x-axis. And so what does motion along the x-axis look like?
Motion, it looks
Straight.
Yeah, it's straight. It'd be like one-dimensional. So this is a graph of velocity representing like the rate of change of position along the x-axis. And so it's like you're looking at a different dimension you're dimensionalizing that change of position, that speed, that velocity by this graph here. So that's what calculus does. It takes us into representations of different dimensions of aspects of something. So here we have, and it might be kind of hard to see, you have the time here, and these are 1 second intervals along the x-axis. And so we're asked the question here, at t equals 4 seconds, is that particle moving to the right or to the left?
I'm gonna guess left.
You guess to the left?
I'm guessing.
What else? Any other guesses?
T equals 4.
At t equals 4, is the particle moving to the right or to the left?
Is it your turn to guess? So,
Guess.
the left. Because it's next.
Right.
Yeah, it's going like
Left.
I want you to look at it and just I want you to make
I know the
a
question.
I didn't put paper.
Oh, we're looking at it. Alright. Oh,
So at t equals 4 seconds, which would be right here, is that particle moving to the right or to the left?
it's gotta be moving left.
right. Right.
You say right, you say left, it's going to be right. Why is it right?
Okay, it looks like it.
But it's negative. Hey, Aaron.
But it's still going right.
Okay.
This is why I'm stupid.
Okay, velocity, here's
Oh,
like the
velocity.
x-axis, right?
Oh. I'm stupid.
And at t equals 4, is that velocity positive or negative?
Positive.
Velocity's positive.
See, I thought it was like.
Now, here's the thing, it's really a deceiving question in that where you're asking about, if this was a position function, well then the velocity would be going that way because...
That's what we thought.
Yeah, but this is a graph of velocity. And so what it would be, it'd be like this. If I'm a particle moving along the line, Gavin, if I'm a particle moving along the line, and I go like this, I'm speeding up, and then I slow down like this, that's what would happen here. Like I'd still be moving to the right, but I'm speeding up, speeding up, speeding up, and then after I'm decelerating here, and as I slow down and get towards that, what happens at t equals 5? 1, 2, 3, 4. What happens at t equals 5? Going up to 6 seconds. What happens at t equals 5?
It becomes negative left.
And then I'm going back this way.
Yes, sir.
Okay? And I'm going back at a faster and faster rate until what happens here at 1, 2, 3, 4, 5, 6. What happens at 6?
That's the point it stops.
I stop right here. Okay? So the velocity is, wait a second, velocity is negative here. Actually, that velocity, I keep on going back and accelerates, but then the velocity stays constant. starting at t equals 6. So I'll still be going left, but at a constant rate. Okay, so over what time let's go ahead and answer the second one. Over what time interval is the particle moving to the left?
5 to, would that be 9?
5 to 9, okay?
I've tried
And are those open intervals or closed?
Let's go ahead and, that's a good question. Okay, on 5 to 9, why is that? Because, now we get to justification, because what?
because it's velocity.
Because V of t is what? Less than 0.
Wow.
Or negative. And so these types of justifications are going to be, this is a very common justification. Or because V of t is greater than 0. Okay?
It's positive.
So very common thing. At t equals 4 seconds, is the acceleration of the particle positive or negative?
Oh, acceleration now.
At t equals 4 seconds, we're back to 4 seconds. At t equals 4 seconds, is the acceleration positive or negative?
It's negative.
Yeah, it is negative. Why negative?
Because the slope is going down.
Yeah, and what we do is and Aaron said, because the slope of V of t is going downward, but I'll say it like this, because slope, let's see, because V of t is decreasing. And Aaron said the slope of V of t is negative, which means the same thing, right? Mm-hmm. So if he says the slope of V of t being negative, it means the same as V of t is decreasing. So Aaron said the same thing, but in different words. 4. What is the average acceleration of the particle over the interval from 2 to 4? And show the computations that lead to your answer and indicate the units of measure. So here we have 2, and here we have 4. I'm trying to see what's on the axis here. I guess I just have to assume these are just one unit apart here. Okay, Gavin, are you working on this? Number 4.
Yeah, acceleration.
Like my song, Mr. G. Oh.
What did you get, Gavin?
I have no idea.
Kylie, what did you get?
Yeah, I'm just
I don't know if that's right, but
Okay, let me show you what I did. Right here is your average rate of change. You're looking at, here's 2, right? Mm-hmm. And here's 4. And so you're going down 3 and over 2. So this would be
oh, that seems simple.
negative 3 over 2. Negative 3 over 2, and what is the computations, I didn't put the computations, but they are here. Okay, if we have, that's going to be 1, 2, 3, 4, 5, 6. So we have 6 minus 9 over 4 minus 2. Negative 3 over 2. Those are the computations. And what are the units?
Feet per second squared.
Yeah, feet per second squared are going to be our units. And then we're asked question 5, is there guaranteed to be a time t in the interval from 2 to 4 such that v of t equals negative 3 over 2?
Yes, because we just did it.
Yeah, so we did it, but what is the proper calculus articulation of what you just said?
Wouldn't that have to do with, like, mean value theorem?
Okay, Kylie just said mean value theorem, right? Because continuous, because we have continuity, because average rate of change equals negative 3/2 according to mean value theorem. There must be a time that v of t equals negative 3/2 feet per second squared, right? That v prime of t, it's hard to see. See that? That's v prime of t. There must be a time when v prime of t equals negative 3 over 2 feet per second squared.
Where?
Okay? And so this goes back to what we talked about here yesterday. You remember we had this thing right here?
Mm-hmm.
This is the right here. Acceleration. Okay, average. You take to estimate acceleration, we take the change in velocity over change in time.
I know, Mr. G. I know. Go in my pocket.
Thank you.
Oh no, got extra fast.
Okay.
Your mom.
Okay, let's go over here. Okay, so we got all that.
Talk to her all day.
Next. Okay, and then we're asked the question related to that graph also, this 6. At what time in the given interval is the particle farthest to the right?
Farthest to the right?
Wouldn't
let's-
it be at 5?
Okay. Aaron asked the question, wouldn't it be at 5? Is he right about that?
I think so.
Okay, now, let's consider, I'm the particle, right? So I'm starting right here at this speed of 3 feet per second. And I move along, getting faster and faster and faster and faster and faster, but then I start slowing down at whatever is 3, and I keep on slowing down until t equals 5. Right? And what happens at 5?
Starts going
0, and then I start going back. So when do I get farthest to the right?
At 5.
At t equals 5. And the reason I do all this walking and stuff like that is
visual representation.
that I want you to visually conceptualize physically what is happening to this. What is happening in one dimension, which is represented by this two-dimensional graph. Okay. Okay, next we have this next problem here, which is example 3, analytic. So we're given an equation. And so what I want you to do is analyze analytically what's happening here. And we'll go over this in a few minutes after you do that analysis, okay? And what were the steps we talked about to do that analysis? Find the critical numbers, very good. Find the critical numbers and use those numbers to analyze and so forth.
Wow, look at me go. Well, pretty smart kid.
Yeah, that's good. Yeah, I want you to go through 3, and then we'll talk about number 4, which is the total distance to. Or if you get through 3 and can start working on total distance, that's fine too.
Mr. G,
Yes.
may I go relieve myself?
Thank you for sharing that with our viewing audience.
Oh, really?
Gavin's gonna go relieve himself. Whatever that may mean.
We know. I still haven't got an answer.
Okay, yeah, go ahead.
Okay, Mr. G.
Do you edit these videos, Mr. G, or do you just do the pure content?
No, I don't edit these videos.
This is unedited raw footage.
Nice.
That's what people are gonna write about me in 100 years. Oh my god.
Can I text you your notes real quick? Saying I can't make it on Thursday.
See, I like that jacket you have there, because that'd be good for whiteout day.
Yeah, that's your fashion.
Cheer jacket, yeah.
For a while.
I have a white jacket too I could wear.
What are your thoughts on the election, Mr. G?
It's, I'm not worried about it. I'm not, people are getting all worked up about it. It's gonna be okay,
About what?
the election, it'll be fine.
I could care less.
I don't want to say I couldn't care less. I don't want to say that. I don't want to go that far, but I'm just not going to be worked up about it.
And like, I can't do anything about it because I'm not.
Well, that's
safe,
exactly it.
so-
Okay, Kai, that's exactly how I feel about it. Since I really can't do anything about it, I mean, I can influence and talk to a small group of friends, but I don't have overall much of an
Yeah.
impact. And so the main challenge is, okay, here's a situation, how do we deal with the situation? How do we navigate? And once we know that, yeah, that's what it is.
To help the multiple.
Yeah, but I'm gonna open it too. But I think so.
Okay, did you finish this nut by now?
Not quite, Mr. G.
I've done the first one.
That's the first one, okay. One thing I do have today for you, and not for Carson, simply because he's not here, is I have the next succeeding packet. See, it's kind of a small packet. Here's your next packet.
And that's the note section.
Yeah, this note card 26 through 30.
First derivative test for local extreme.
Ah, extra.
pretty sure it's extreme.
But I like the word extreme.
Like eczema?
Eczema.
Eczema?
I have eczema.
Oh, that's fun.
You got X?
I do.
You got X? Yeah. I'm sorry.
We're disappointed.
You're disappointed that I have eczema?
I am.
I don't. Okay.
Not really.
Sorry.
So I was just kidding.
Okay, at t equals 0, is the particle moving to the right or to the left?
I said to the right.
To the right.
Because when you plug it in, it's positive.
What'd you say, Hannah?
The right.
To the right? You got right?
Exactly what Callie said.
Okay, good work. Good work. Let's go ahead and write that down. So here we have v of t equals x prime of t equals, is it 3t squared minus 12t plus 9.
Thank God. Listen.
Okay, to the right or left, and how would you articulate that? You said right because what? Because what? How do you justify that?
Whatever, is it x? X of 0?
The velocity is positive.
It's positive.
Yeah, so v of 0 equals 9, right?
Mm-hmm.
Since
No.
I got it.
Oh.
since v of 0 is greater than 0, moving to the right. Now, some of you expressed surprise by what I put down here. Do you see that?
I just didn't do the prime. I just did it regular.
Oh.
Okay, because the velocity is your first derivative of position, right? And since our value, if we plug in 0, is 9, and since v of 0, which is 9, is greater than 0, particle is moving to the right. Okay. Next, at t equals 1, is the velocity of the particle increasing or decreasing?
Now I'm stuck on this.
Okay.
I definitely
I-
got it wrong. So,
Yeah, I looked at it.
Okay, here we're going to go a of t, which equals v prime of t, which equals x double prime of t. You see that relationship here?
yeah.
Velocity is the first derivative of position, and acceleration is the first derivative of velocity, yet the second derivative of position. So we take the second derivative of this, which is going to be 6t minus 12. And then we're asked, at t equals 1, is the velocity of the particle increasing or decreasing?
It would decrease.
Okay, let's say v, okay, a of 1 is equal to 6 times 1 minus 12, which equals -6. So since how do we articulate this? Since a of 1 is less than 0, velocity is decreasing, right? And we saw that earlier, right here, when we looked at the graph. that velocity was decreasing, right? Velocity is decreasing. In fact, it decreased so much it got to 0 here, and then started going negative. But the velocity was decreasing all the way from t equals 3 down to t equals 6, I think it is. Okay, let's go ahead here. Find all values of t for which particle is moving to the left.
So,
Is there to find the critical numbers?
I'm seeing to the left.
So what I'll do is I'll set this equal to 0, and what am I going to set equal to 0?
The VT?
This guy right here. So I put 3 times t squared minus 4t plus 1, is that right? Or is it 3t plus 1 is 3t? 3 times, no, it's going to be 4 minus 4t plus 3, is that right?
Yeah.
So here we have, what is that going to be? 0 equals tt,
Positive 4 minus 1, so plus 1 minus 1, that one?
no, you have to have minus minus,
Oh.
3, 1, right?
Yeah.
So find all values where particles moving to the left.
Number line.
So now we go ahead and do this.
Oh, the number line.
So negative 1, so 1 and 3, right? And we're going from, it doesn't say, it doesn't have time limitations, but starts at 0 here. So what happens to the left here?
It's positive.
We have negative, negative, so particles moving to the right, then positive, negative, particle is moving down, and then positive here. So what is our answer here?
1 to 3.
Okay, and what is our justification? Because,
It's less than 0.
yeah, remember it, don't use it, because v of t
It's less
less than 0. Okay, so on the interval of 1 to 3. Now Aaron asked a question about open interval or closed intervals. Most of the time you're going to be using the open intervals when you talk about velocity or acceleration, because you can be less likely to be caught in a trap of where you're wrong by doing that, I guess is what you say. Okay, find the total distance traveled by the particle over that interval from 0 to 5. So what are you going to do with that?
I don't remember.
Let's go ahead and put what it is. We go ahead and put 0 to 5. So we have t and x of t. So 0. And what are the critical numbers?
critical numbers are 1 and 3.
1 and 3, and then we want to go till 5, right? Well, if we look at, so we look at this equation right here, and you say, well, that's x of t, right? So what is our initial position here?
11.
11. And what do? We put in 1. Now, remember, velocity is positive to the left of 1. So should we expect this to be a higher number or a lower number than 11?
Higher.
Higher, right? So let's go ahead and put 1 in here. When you put 1 in here, the arithmetic's pretty easy, right?
Yeah.
So we have 1 minus 6 plus 9 plus 11. 1 minus 6, that's negative 5, plus 9 is
15.
4, plus 11, 15. So how many meters did they park travel here? 4 meters, right? 4 meters traveled. And then we plug in 3, which is going to be, okay, x of 3 is equal to 3 cubed minus 6 times 3 squared plus 9 times 3 plus 11. Now, should we see a bigger number than 15 or a smaller number than 15?
Smaller.
Smaller because we should be moving to the left. So just think of these things as you go because that'll help you. So we have 27 minus 6 times 9, 27 minus 54,
Negative 26.
negative 27, plus, so that's negative 27, plus 27, so that's going to be 0, right? Plus 11, so we're back to 11 here, right? So how many meters did we travel? 4 meters. Did we travel negative 4 meters? Yeah, we did, but we're interested in total distance traveled, right? So we're interested, you put negative 4, but you're interested in the absolute value of that.
Like you did negative 4, but you're not supposed to put negative 4, is that what
Yeah, that's it, because this is 4 meters traveled is what I'm putting. So we went 4, 4, and then to find out how far we went in our last hitch and where we are, we put x of 5,
It's 31.
5 cubed minus 6 times 5 squared plus 9 times 5 plus 11. And you said it's 31, Aaron?
31.
Okay, I'm just going to trust Aaron on this. And so this is going to be 20, right? So what was our total distance traveled?
28.
28
Meters.
28 meters. Okay, so really that's going to be it. So let's just leave it right here today.